Okay, thanks for coming to this talk. I know we are really far away within the OCP Summit this year. My name is Jean-Marie Verdun. I'm a Senior Distinguished Technologist at HPE. I'm here with Arun Koshy. We both work in the same team. Arun is focused on system automations and testings. I'm more focused on open source firmware and low-level implementations of hardware. So we are here today to discuss about some testing that we have done with AI and based on the current tool that we designed and trying to understand how AI could probably help us or not based on what we have designed in the past. So just as a quick turnaround, we believe that AGI is not yet ready following the testing that we have done, definitely, and you will see the outcome during a quick demo. So we have published this work through the OCP Foundation GitHub, so feel free to get to this GitHub. You'll be getting full access to these testings. So roughly what we did is we published in the past a few tools through the OCP Foundation GitHub, like OSFCI, or full test and automation of systems. And we injected the source tree of these tools into a different AI model and asked these AI models how to improve the code, what the code is doing, and what can we do to enhance the various testings. And Arun is here to explain you the outcome.
So I'm just trying to make sure that we've got the demo, because we've got a live demo as well. So where we stand right now, I think what we've come to realize is that, oh, you switched to the live demo. That's great. Okay.
What do you need?
I need the demo screen on my laptop.
I think it's there.
Yeah, okay. Okay, great. So I think what we are starting to realize is that we have pretty much come to the same conclusion that many in the industry are coming to, which is that hallucinations, jailbreaks, and indirect prompt injections, they don't really have a fix. So they're part of how these things work. The second thing that's of interest to us is that the power or compute consumption actually is a sign of trouble. Because if you think about it, our own humble brains take about 20 watts. And so the current metric is we just keep burning more and more power to power up these models. So that's another tell that we may not be at where we need to be. Many experts believe that scaling will continue to pay off, but that will not lead to generalized intelligence or a reflection on how to have firm causal reasoning within these models. So currently the math that is in prevalence is curve fitting, but there's also people like Judea Pearl who have been trying to drum up the warning signs that we don't really have causality baked into the current approaches. So what we decided to do is try to make it concrete, which means that if you want to test how these things work, it probably is a smart idea to bring it to what you know best. So we tend to know a couple of the things that we are working on really well. So for example, the OCP Diag core frameworks, or the CI that Jean-Marie and I worked on together for testing firmware. So we believe that a good test would be to use these models to try and interrogate these things, which are interestingly also low distribution use cases where they're not that prevalent in the LLM corpus. So you're really going out into the tail of the training set, which means that the chances for these things to make errors might be higher. And as we found out, that it's exactly the case. Big picture, LLMs broke the Turing test. So there's a well-known paper in Nature which talks about the fact that the Turing test was found to be less than sufficient because clearly LLMs convince a lot of people that they're intelligent. That's why we are here. However, that's actually a break in the test itself, in our opinion, not the fact that they have achieved true intelligence. So there are some really interesting efforts like the ARC price movement, which talks about testing for AGI. It is a very well-regarded community at this point. My own personal favorite is that we have these open millennium problems. That is the hardest unsolved math problems. And the day we see any kind of machine learning model solve these from ground up and present a thesis defense to a bunch of human peers and prove itself, that would be an interesting day. But that day is not here yet either. So I think these are some more robust ways of testing whether we are on the right track. I think now I can go to my demo. Hopefully it should work. Yeah. So at HV Labs, we had set up a couple of clusters that allow us to deploy some of these models in a private capacity. One of the positions that I'm taking is that long tail, even if we are persisting with this direction, I think people would be more comfortable in privately owned AI models rather than trying to have a feedback loop with any organizations outside, whether it's Anthropic or OpenAI or any of those. We believe that the future, especially for sensitive customers, they might want to do this in a private capacity. So the OCP wind tunnel project actually is sort of a kickoff from the test and validation group that we were discussing. So you could find all of what you need at the repo to set up your own private cluster, maybe run your own chatbots based on the popular models. We ran a bunch of tests across the top few models that we could find, both public and private. So we actually have a local instance of DeepSeek and Llama running at our private cluster, and then we also have a subscription to Claude and GPT. So we just gave it a standard set of prompts from scratch, very well-known prompts, and I had the results from my colleague who leads this project. His view is that DeepSeek is about 70% correct. The output is completely wrong. It's not using any of the Python API and just hallucinated some of the new API object. Cloud adds a bit of fancy stuff. It may have 5% hallucinations, much more comprehensive than the GPT-5. GPT-5 is the only one that actually did this simple test case from scratch. In his view, it would run, it would produce the correct outcome, but it's simplistic, but it does what he asked for. We also did something with our own OSFCI, and I wanted to do this live to put Jean-Marie into a bit of a spot. So this one is querying DeepSeek about, hopefully it should work. And this one is querying CodeLlama. Hey, you can take this.
The idea here is we have to onboard the new engineers and provide the code to the new engineers and try to see if AI can provide a relevant documentation of what the code is doing. Let's envision we write code without any documentation. And many people will say code is self-describing, and we are just trying to figuring out does AI can self-describe the code or not. And by knowing the code, when we look at the output, just asking the simple questions, can you explain me what does this code is doing? The result is just catastrophic in some way. So that code description is just roughly a quick scanning of the code, but it doesn't provide any insight of what the code is really doing. And this is a key challenge is to us to use AI. And this is bringing us to the questions around, do we need specific LLM implementation for testings and validations? And do we have to work as a community on this specific implementation or not? But none of the models that we tested were able to provide any kind of relevant explanation of what the code is doing from the GitHub repository. We were a little bit surprised about that outcome. I was expecting better results because the next step would have been, can you write me a test which can work with that framework? But if the AI model is not able to explain what the AI framework is doing, so heading to the next question is something which is really tricky.
So I wanted to show you something like this one is actually a misfire on Llama's part. It misfires saying that there's something to do with the ethics about control 1.go. It's perfectly, innocuous code that's part of our CI that's open source. The more broader problem, and I thought this was really funny, is that Andrej Karpathy, who's a very well-known deep learning guy, he has this new thing called out NanoChat, which is like a micro chat that he implemented. He was asked the question online on Twitter, saying, curious, how much do you write the code by hand of it? And his answer is exactly featured. Good question. It's basically entirely handwritten. I tried to use Claude Codex Ages a few times, but they just didn't work well enough at all, and net unhelpful. Possibly the repo is too far off the data distribution. So we are again seeing the same trouble, is that the more your particular world is outside of the aggregate data distributions that were used to train these things will continue to disappoint. Judea Pearl is one of my favorite people who kind of openly makes fun of the whole deep learning thing because he believes that we're kind of attempting alchemy where you keep trying to put bigger and bigger engines, quote unquote, compute, and suddenly you'll get to causality, which is his argument. When you wire up these things yourself, you also get to instrument them properly. So you get to see what all's happening. And since we are deep into systems, we've written a bunch of monitors, and we want to continue to expand on this work. So getting back to the presentation, yeah, so our hope is that we would like the community to think about this idea of bringing the testing of these models more into the real world and using real use cases that are, less than the ones promoted by the current wave of marketing and the hype and all of that. We would like to broaden the scope of this particular tooling beyond, of course, test and validation, because I think it's interesting to go at it from the domains of, the basic idea is, I know this domain really well, and therefore let me test it on this particular area that I know really well. That's sort of the rough picture that we are trying to get to. So at this point, yeah, these are all the references. Thank you. If there's any questions.
So you use the AI to help you generate the scripts, or you just use it to do some summary and like that?
So we didn't start from scratch. So we had existing applications, and we wanted to enhance these existing applications. So the idea behind it is we have a test framework, and we wanted to first have an explanation of what the test framework is doing. So can we run automatic documentation of the applications without having it, just to see if, I would say, a student or new developers might be able just to benefit from that explanation. And roughly AI failed the test. It's probably related to the fact that the application is coded in a way that it might be a little bit tricky to understand, and the way the AI models are trained do not take this into considerations. But this is really massive failure, so none of the description are efficient. And the next step was, as this is a framework which is able just to generate tests and get new testings, we just wanted to see, can we generate new testing? So like, how can we stress test the memory, or can we stress test a subsystem into an hardware, a new generation of hardware? And that failed too. It doesn't mean that we are against the use of AI. It means that we wanted to use AI. We failed at using it for our own purpose on a very specific domain that we are involved with every day. And we are just trying to bootstrap that internal program inside OCP just to try to fix these issues. Because AI is going to be there to last, but we definitely need to try to figuring out how can we improve it just to make it usable for our own very specific topics.
I see, thank you. What I observe is if you expect AI to just run, sometimes it doesn't work. But if you use it to proceeding the documents, it works.
Yeah, so I think the key aspect is how there are a couple of things. One is most of these models are probabilistic in its outcomes, right? So essentially you're dealing with a probability measure at every level of this game. So if you want firm deterministic outcomes, I think the current models are probably not the right fit. Also, in our view, the higher the stakes are and the more it is not represented within a distribution of the training set that were used to train these models, the more dangerous it gets, right? So I don't think it's doing anything wrong. I think it's doing exactly what it's purposed to do, and that is the problem. Because of the fact that scaling has gotten us so much of popularity, people have sort of fallen into this. I've watched a bunch of the talks here also where they've said, oh, AI will get better at understanding. But the fact is, this is not understanding, right? So the models aren't understanding. The people who innovated or birthed these things, they'll be the first to tell you, whether it's Jan LeCun or any of the guys, they'll say, this is not understanding. In fact, he makes fun of this on Twitter, saying that the average GPT is probably not smarter than your cat. So I think that's where this disconnect is, and it gets more and more exposed, especially as you deal with more interesting use cases where there's not a lot of training corpus.
We're running out of time.
Okay.
So we are running out of time. Thank you very much.